The title of this presentation is You Move This, Annotation of Pointing Gestures on Tabletop Interfaces in Low Awareness Situations. Thank you very much for listening to this talk in these situations. My name is Dimitra Anastasiou, and together with my colleagues Kurie Afkari and Valerie Makil from Luxembourg Institute of Science and Technology, the IT department, we have conducted a user study within the project Orbit, which is about collaboration and awareness situations. And we wanted to see in this paper how gestures, and particularly pointing gestures, are a mechanism to raise awareness. So the overview of this talk, I will begin with a research goal and motivation and one research question that we pose for the user study. Then we'll continue with the definitions of collaborative problem solving and awareness, particularly in the domain of tangible computing. Then I will describe our user study and show some pictures and gestures as well. And then I will continue with the data analysis, how many gestures we found per group and so on. And I will conclude with some future work. So the research goal is to explore how the pointing gestures are performed to re-establish awareness during collaborative problem solving using a tangible tabletop interface. So in Luxembourg Institute that we're working, we have experience in conducting studies on collaborative problem solving using tabletops. However, this study was particularly to see how gestures pointing on other users' area, let's say, would have been used to raise awareness. And we will see later some awareness, some low awareness situations that may happen. The question is, are pointing gestures related to low awareness situations? And if yes, how? And with this research question, what we want to target is to add as an additional awareness mechanism that pointing gestures towards other users' personal areas have an impact, so that they raise the awareness. So collaborative problem solving has been defined by many researchers since a long time, but we follow the definition by Griffin in 2012, who said that the abilities to recognize the points of view of other persons in a group, contribute knowledge, experience, and expertise in a constructive way, identify the need for contributions and how to manage them, recognize structure and procedure involved in resolving a problem, and as a member of the group, build and develop group knowledge and understanding. So as we see here, it's not only being a team player, but also identify the need for contributions, manage them, and resolve a problem. So it's a lot about interaction, collaboration, and also consensus, finding the consensus and develop group knowledge. Let's go to the definition of awareness. So according to Doris and Bellotti, awareness is an understanding of the activities of others, which provides a context for your own activity. So in general, awareness is about the context. During collaborative activities, awareness is considered very crucial, because only when we see what the context is, then we can collaborate effectively. And Ensley said about situation awareness is actually what is going on, so knowing what is going on, and this involves states of knowledge as well as dynamic processes of perception and action. So according to F. Hornecker in 2008, she has explored awareness in collocated settings, so among multiple users, through negative and positive awareness indicators. So some negative awareness indicators are interference, for example, reaching for the same tangible object, and also verbal monitoring, such as when a user asks, "What did you do there?" Positive awareness, from the other point, is when the reaction is done without explicit request, or a parallel work on the same activity without verbal coordination. So in the positive awareness indicators belong, so to say, no speech or no explicit request. So when everything goes fine, we don't ask questions, or we don't really communicate, we just coordinate between the objects. So as I said previously, the user study has been done within the context of the Orbit project. Orbit is a funded project by the Luxembourg Research National Fund. And the goal of this project specifically is to enhance users' awareness of their collaboration strategies by providing them with tasks and tools that induce their collaboration and create overall a positive user experience. The user study that we conducted for this and this paper is about was done with 15 people, split into 5 groups. The participants didn't know each other, and they never used a tangible tabletop before. And this is in line for using a tabletop interface to collaborative problem solving. So this is like a requirement for our user studies. The background was very heterogeneous. We had 6 employees of municipal departments, 6 elementary school teachers, and 2 computer science researchers, and 1 civil engineering researcher. The groups were gender and age mixed, and they spoke in different languages. 3 of them in Luxembourgish, 1 in French, and 1 in English. But we have shown in previous studies that this didn't have an impact on the gesture performance. However, we didn't check this in this user study. So this is the so-called micro-world scenario, what the users see on the tabletop interface. Orbitia is the name of this micro-world. In other words, a micro-world scenario, or simply micro-world, is an instantiation of an artificial environment that behaves according to a custom set of mathematical rules or scientific subdomains. Orbitia here is an imaginary planet where the users are needed to act as a space mining crew in order to mine valuable minerals and ship them to Earth. So the main task of the participant is to steer a rover, as you see here, and operate a radar drone, which is not here because it is a tangible object, which is running on the planet's surface to find and collect required minerals. In parallel, participants need to deal with limitations of the environment, such as different obstacles, energy and movement constraints. So here you can see, for example, some sharp rocks or a low energy, here that the batteries are low, or some canyons. These are some cells marked darker than normal grid cells. And of course also some dust storm area. For example, here, as you can see, it is a part of the grid which is more cloudy like. So the items might, for example, the diamonds might be there but are hidden, so it's a more complicated task for the user to find them. This is why they need the radar. As you can see, is a lot of design behind of this micro world, so, and it might need more time to describe this. So I will continue though with the personal areas of the users, because this is more important for this study. But if you have any questions or any feedback on this macro world, feel free to contact me or my colleagues, because they have done the design. So as you can see here on the top down, I don't know if you can read it, it says my mineral control panel, and on the left it is energy control panel, on the right is the damage control panel. Again, it is here, and I will go back. These are control stations or control panels, which are, so to say, the personal areas of its user. So one user was placed in front of the areas, and they were supposed to be responsible, let's say, for this area. Although we didn't explicitly said that to them, so this was understood from the real beginning to the users. So some examples of low awareness situations that happened during our user study. So when did user, let's say, had low awareness? First, when there was new information was revealed, for example, a canyon or a dust storm, or a danger, or the battery was low. So there were new features or hidden items, as I say, and users were not familiar with them. So then the users started to ask and point to each other, because it was they were not familiarized. Another thing was that a suggestion for a route is made, but some users, might be one or more, were a bit hesitant. They didn't know if the suggestion by the other user is correct, so they were inactive. They didn't speak, or they didn't move any tangible object, they didn't press any buttons, and so on. The third indicator was that one or more users took a bad decision by moving the rover towards an unfavorable cell. So they really took the decision, but it was towards the wrong direction. And the fourth indicator was that they disagreed verbally. So we focused though on the annotation, only on the gesture, so we left speech aside for the moment. And we categorize gestures into three types. When one user pointing to another user's area, so user A points to user B. This is here. You see the woman on the left points to the control station of the user C on the right. For example, when the battery, if you remember, this was the battery, when she realized that the battery is down, but the user C didn't realize this, then the user A made this clear to him, if she thought that he is a bit hesitant and inactive. The second category is when two users point to another same user's area. This is here. User A on the left and B in the middle point to the user C on the right. This happened, for example, when again the user C might be inactive for quite a lot of time. So both users are pointing. Indeed, this kind of gestures happened less often than the first, because when actually a user sees that the other user is pointing, then they retract the gesture. So it is a bit uncommon that both users pointed simultaneously at the center, at the control panel of another user. The third category is that the user A points to user B and user C points to user A area. This is when you have the complete mix, so when one user points to another and the other user points to the third user. This was the most uncommon case, because again, when a user saw that the other user is pointing to them, then they retracted their gestures in order to listen and assess what the other user is trying to say to them. Yes, the fourth category is when one user pointed not only but also touched the other user's area. No, I don't have a picture here, but imagine that it's not only pointing but really touching. This happened, for example, for people who, for users who, when they were pointed to, they still didn't react. So the user who pointed wanted to make this even clearer. So went a step further and really touched the button on the other user's area. So we analyzed the data. We had 170 minutes approximately of audio-visual recorded material. The data analysis was mostly quantitative. We categorized into two measurements. This is typical for measuring, for assessment of collaborative problem solving. We assess the response time of the full task and also the trials and errors. And for each micro-world scenario, we of course define what is an error. And for this user study, of course, we also measure the pointing gesture occurrences towards other users' personal areas, which is the biggest focus. But let's continue with the response time and errors. These are the 5 groups. So as you can see, the group 1 and 3 took the longest time, so about 50 minutes, the group 1. However, no errors, so they really talked into detail. So 0 errors. But noteworthy is that the group 4 and 2, which were the really fastest groups, with 24 minutes, you see group 4 had 0 errors. However, group 2 had 8 errors. This means that even if a group makes trials and errors, does not mean that cannot complete the task well, fast. However, the performance is a combination of response times and errors. This is why the group 4 performed overall better. Let's continue with pointing gestures toward other users' personal areas. Here in the table you see all the gestures performed by user A, B, and C. As I said before, user A was on the left, B in the middle, and C on the right. The biggest number is group 1 and group 3, which is to expect because the response time was higher in these two groups. However, if we take the relative gesture numbers, which is gesture per second, the group 4 performed most gestures. So we can deduce that the more frequent, because if you remember that the group 4 did not do any errors, we can deduce that the more frequent the pointing gestures produced by the groups, then the less number of errors they made. In my previous research, I have conducted other studies, as I said, and I have a gesture taxonomy, which involves both gestures made with tangible objects or with a tabletop as such. These are called manipulative gestures or touch-based. For example, when a user places an object, removes it, drags or traces, rotates it, and so on. And we also have the mid-air gestures. These are the 3D gestures done with the hands in the air. Pointing includes, of course, pointing to an object, but also to another participant or a self-pointing to the self. However, I added due to this user study some extra areas, which is the personal area of other participant. And also pointing and touching. So not only pointing, but touching the personal area. There were some other categories, for example, iconic, but also adapters and emblems like thumbs up, and adapters, the, the unconscious gestures, for example, head scratching or mouth scratching. And as in many studies in collaborative problem solving in tangible computing, we have a combination of manipulative and mediated gestures. As for future work, we plan to have more user studies with Orbitia. Orbitia was the microworld scenario. We will include more groups speaking the same mother language, so not to have the other variable of having different mother languages. We will run inferential statistics to confirm the significance, the statistical significance between gesture occurrences, error rates, and response times. We will enhance the annotation on speech, first of all, and also the reaction of the pointed person. This is always very useful to annotate because now we annotated only how the person who pointed to whom, but we didn't answer if the person, if the user who was pointed, did they say something back to the user, did they do nothing, or did they make another gesture, for example. And on the top of that, the semantic connotation of the interference. When a person really pointed to another person, was it right or wrong? This has to be seen a little bit in the time frame. We have to see the full task, and in the annotation see how this is supported by the next steps, let's say the full process. And last but not least, also facial expressions and eye gaze, which are some other non-verbal behavior indicators. We also plan to use automated systems for gesture recognition so that we save time for the time-consuming task of annotation. This is all from myself. I have here my email and also of my colleagues. You can see the link of the Orbit project. It is www.orbit.team. As I said, it's funded by the Luxembourg National Research Fund. Thank you very much for listening to the presentation, and I wish you all a happy post-exit of the coronavirus crisis. Thank you. Bye-bye.